Okay, great. So Mike is on and oh, thank you for closing the door. Um, let's hide the meeting controls. Make sure that works. Nope. Okay. So good morning and happy Wednesday. Today marks 5 weeks into the semester. Hard to believe that February is coming to a close. I have a little bit of hoarseness in my voice, the usual kid brings stuff home, family gets sick type of thing. So excuse my voice sometimes if I need to cough. So that being the case, today marks 5 weeks into the semester, and we only have 10 weeks left to go to talk about everything that we will touch upon for this course. Um, when's spring break? Spring break is it in April or is it in 2 weeks? Oh, wow. Okay. That was fast. All right. So before we begin, the usual administrative bits. Um, homework number one is due this evening, and please make sure that you're handing in all of the required components, particularly certainly your written portion, but also the presentation. We do have one of your colleagues, for various reasons I won't talk about, joining us via Zoom. Also, written exam number one, and it's my style to talk about or announce the exams a week in advance. It will be a week from today. And my style, for those who've never had me for a class for written exams, I like to ask thought questions akin to what you would get on a project or a homework, but certainly it's not going to be as involved as a project and a homework. I scope them to take you about an hour and 15 minutes or so, plus or minus, depending on how you prepare yourself. And I have a 24-hour take-home format. And so what happens, the exam will auto-release when class begins. And I use the class period to go over all the questions, to put you in the mind space of the questions, and to also make sure they're to provide any clarifications, rather, if you have questions about what I mean by the questions. And then you are free to find your own time and venue best or most conducive to your success in which to set the exam. Now, you're certainly welcome to stay here. I'll be here. And if you want to set the exam immediately right there in class, you're welcome to do that. Also, you're welcome to find a venue that's more conducive to your success. And so if you feel that, okay, well, rather take a nap and then set the exam, maybe you're more productive in the afternoon, then albeit, please go ahead and do that. Question. Ah, and so there will be a written component. There will also be a practical component involving a Jupyter Notebook. I haven't written up the exam yet, so I don't know 100% what the form is, but there'll certainly be a written component as well as a programmatic component, specifically using Jupyter Notebook. Um, and so, let's see, I forgot what I was going to say. Did I answer your question? A little, okay. And so it'll be electronic, and of course, with great privilege comes responsibility. The exam will be released with an honesty statement, and I will not accept your exam without a signed honesty statement. And you can sign it however you choose. Doesn't need to be a physical signature, could be a digital signature of some sort. Please, it is individual effort and to be treated like a traditional exam. Please don't put me in the uncomfortable situation related to academic dishonesty. No collaboration with your colleagues. Nothing personal. It's not fun for me, not fun for you. If I have to deal with that stuff, I'm just doing my job. Okay. So it is an individual effort, and you're welcome to use whatever resources you find useful to you. So it's sort of open book, open notes, but closed colleague and closed human. All right. Any questions about the exam? Yes, a study guide. Um, I can do that. Anything up to and including today is fair game. And because it's open book, open notes, Of course, I like to have a lot of thought questions. I would never ask you to memorize and regurgitate things. So I could certainly do that. What I would do is go through all the slides and look at all the material and look at my original course plan and just give you a bulleted list of topics that we've covered. So I can certainly do that and probably make it available on the Slack channel or something like that. Okay. I'm sorry. Both. Everything is fair game. And so we've talked about things about counting, about complex events, about conditional, so-called filtering probabilities. We talked about Bayes' rule. We talked about random variables. We talked about sampling. We talked about populations. We talked about NumPy arrays and slicing. And now we're talking about data frames and some of the pandas material. Okay. Can I answer your question? Yeah. Any other questions? No? All right. And so, whether you believe it or not, I'm not out to kind of get you on the material. I really do want you to be successful. So please make sure you prepare for it. And if you're doing all the exercises, doing all the projects, and you're understanding everything that's going on, you should be fine. If there's any question that you have about the material, please do not hesitate to reach out to me. If my office hours, 10:30 to 12:30, today on Wednesdays doesn't work well for you, I'm more than happy to arrange another time by appointment with you to chat about material or life in general, if that's what you want to chat about. All right. Any other questions? No? No questions? All right. And so with homework one, please resist the temptation to want to just jump in and solve it without going through those heuristics that we talked about. You're assembling a set of events and you're enumerating them by selecting objects in various ways, with replacement, without replacement, where the selections either have duplicates that are distinguishable or indistinguishable. Okay. Any questions? No? No questions? Okay. Also, there have been some flyers posted around the department about a survey, feedback for students. I'm actually a committee member for a Computing Research Association. It's a national board, and the whole goal of the association is to advance computer science, in particular on the research side. And it kind of is tuned to the graduate level, but not just undergrad. It's all computer science, undergrad and graduate level. And so one of the things they do is they study various things about the discipline. And this particular thing is a survey that gives you feedback about education and things like that. So please take the time to participate in that survey, whether you are a computer science major or not. You're certainly a consumer of computer science education, and your opinions do matter. Also, there will be a seminar Thursday, tomorrow, from 12 noon to 1 p.m., navigating graduate education. Right. And so this workshop of sorts, we'll be talking about graduate school. And so, it's part of my job to do this, but I certainly hope that all of you are considering graduate school. Personally, I found grad school much easier than undergrad because your attention span wasn't divided into as many different subjects. You got to really explore a smaller number of subjects. I was an undergraduate in electrical engineering, so not computer science. So it was a little bit different, and it required me to kind of get up to speed on some computer science stuff that I hadn't had as part of my undergrad curriculum. But graduate school is a lot of fun, and especially because you're young people, you don't have as many responsibilities mounting up. So I would say if you have a chance to go to graduate school directly out of undergrad, please take the opportunity to do that. Just kind of get it done. And what it does is kind of gives you more opportunity. It opens up opportunity for all sorts of things, whether you want to go into academia, go into government service, go into industry, hang your own shingle, start your own business, all sorts of things. It teaches you how to solve problems. At the undergrad level, you learn how to solve problems, but at the graduate level, you learn how to ask the questions that you then solve. And the difference between the master's and the PhD is that for PhD, you're learning how to make original contributions. Effectively, you could say invent something, if you want to put it that way. Any questions? So please do. Graduate education in computer science is typically free in the United States, and you're often supported by research grants as well as helping out with the academic side, tuition waivers and teaching assistantships. Any questions? No? All right. Are people interested in grad school? No? Thought about it? At a minimum, I'm also happy to chat about it on CRA. I'm in the CRA Education Committee, and one of the things we look at is growing the ranks of graduate students who go into graduate school. Because from a national standpoint, it's considered a competitive advantage if you have more people who can do research, need the next generation to kind of take over from those folks who are doing it now. Okay, so please do attend if you're interested. It's always good to know and get those questions answered. Okay, so when we last left off, we talked about, did I record? I can't even remember doing, yeah, I think I did. No, I can't remember. I'm getting kind of, yes, I am recording. Okay. It's sort of like a reflex, and I can't even remember that I did the recording. All right, so where we last left off, we talked about data frames, and we said it's a two-dimensional data structure, and it's the main focus, along with a series of the Pandas API. And so as a two-dimensional data structure, it has rows and columns, and we said underneath the covers, it's structured as an array of dictionaries and a dictionary of arrays. I keep saying that backwards. And so here in this construction of a data frame, we presented this to kind of show you what it looks like. And a dictionary is a set of name value pairs. But in the case of a data frame, those values are lists, they're arrays. When we extract out one of the columns from this two-dimensional data structure, it gets wrapped in another object type called a series. And the reason why data frames, the 2D array, and series, the one-dimensional columns from this 2D array, the reason why they're presented as objects is because you can associate all sorts of useful functions or methods with the data underneath the covers. Okay, any questions? No? Draw your memories? All right. And so we said, and gave some examples, we talked about the slicing notation, and you can slice out a column's worth of information from a data frame using the key value, where the key value are the keys, the name part of these name value pairs for our dictionary of arrays. And those are effectively the column names. And so we use array access notation to effectively slice a column's worth of data from the data frame by just using that key value in our array access notation. And so in this case, we slice out the age column, which is this array containing 22, 35, and 58 in this example. And now we can exercise all sorts of methods, and this is not exclusive of all of them. There are too many to talk about. We can take summary statistics like the mean. We can take the min and the max, and that's very useful for all sorts of things. We can also fill in values that are missing, either explicitly or by interpolation, and there are many different types of interpolation. Okay, any questions? No? No? All right. And so one of the things you can do, this is pretty useful, for the entire data frame, every time you call one of these special methods, it will iterate over all of the numerical columns for you and apply these methods. Now, in this case, this sort of pseudocode that looks like correct Python, but it's not really Python, we have, oh, that actually is a typo, it should be ages. We can call describe. No, that's right. We can call describe, and describe will give you a lot of popular summary statistics. In this particular example, we have mixed data types. There are two that are string arrays, name and sex. And then we also have a numerical column, age, with these values 22, 35, 58. So in this case, when we do a describe on the data frame, it applies to all of the numerical columns in our 2D array. And so it computes these summary statistics for that one numerical column. If we had, for example, age and temperature, where temperature were also numeric, it would have an entry for temperature computing all of these summary statistics. Any questions? Does that make sense? Jar your memories? Yeah. All right. And so we also, instead of just constructing our data frame, you can load a data frame, or rather take data off your file system in some file format and ingest that into memory, and it will instantiate for you a data frame populated with this information. Now, of course, the assumption is that on-disk format is in table representation, right? If you have a three-dimensional array on disk somehow, you can't treat that like a data frame. Maybe you could take, each slice in the three-dimensional array, consider it a different data frame, but data frames traffic in two-dimensional arrays or tables. And so we showed the read CSV API for Pandas, and we had an example in Jupyter Notebook, which we'll spend the bulk of today going through some other types of considerations for the data frame and series using the Jupyter Notebook. And so certainly you can read it into memory. In this particular case, we're reading titanic.csv, which is a CSV file containing information from the manifest for the Titanic cruise liner. And then if you have a data frame in memory, you can write it out to one of a number of different file formats, in this example, to CSV. Okay. Any questions? No? And so you can also visualize. And with this visualization, in this particular example, we have two numerical columns. We have name, value, pair, length, and width. Each one is an array of 5 elements. And we give this thing an index. And when you give your data frame an index, you're overriding the default, which is the offset, a numeral representing the offset into each one of the arrays for the data frame. And so here, if we compute histogram, we call hist on that data frame object, and we set the number of bins optionally. If you don't include a bin count, it'll default to 10. And this will go through the data frame and compute the histogram and display it for each one of the numerical columns. And so we get one for length and we get one for width. And you notice by default, it gives you a title, and that title is exactly the key for each one of those name value pairs, dictionary entries in the data frame. Any questions? Does that make sense? Yeah, all right. And so we also, excuse me, talked about insertion. Let me move this down a little bit. We talked about insertion, and with this we have two columns, column 1 and what we're calling column 2. Each one of them is a dictionary entry, name value pair. And so in this case, we have the default index, and you'll see we have offset 0 and we have offset 1. That offset, as we said, the default index represents the offset into each one of the arrays, representing a column in the data frame. And so now we can insert a new column. And that would be very useful for what we did with project number 1, where we inserted that string array, which was the month and year label for each one of the entries for the spaghetti meatball index problem. Okay, any questions? All right. So why don't we, continue on. And we're going to look a little bit at series and have some data frames thrown in. And then we're going to spend the bulk of today, actually in the Jupyter Notebook, looking at a bunch of things. And so here we have a data frame. And as we said, we can slice out a particular column using the key value. And here we're taking the age series out of this data frame, or the age column. And so we do that, and it'll display it to the screen. And here we can exercise now, whether on the series or the data frame, usually many of the same API calls, these very useful functions. And so, for example, say if we assigned the result of slicing out the age column to a variable called seer, and we might have these numbers with the default index, you might want to have the absolute value of that series. Now, certainly you have the absolute value function available to you inside of Pandas series. You can call absolute value, give it a parameter of a series, or you can take the series object reference itself and call it absolute value. Now, you notice here, when I call ser.abs, there's no parameter specified. And so if there's no parameter specified, the data that it uses is the data inside of that series object. And in this case, series has an array, and it has numbers 22, -35, and 58. We take the absolute value, and the difference in the display is the -35 is now 35. Many questions? Does that make sense? And again, I can't possibly cover every useful function available. We probably would take a month or two to do that. Another one, we talked about this idea of a placeholder for entries that are missing, so-called not a number. And so when you pull a file into memory, if you don't have a value, you have to still put something there in that entry for the data frame. And that something is the not a number, np.nan. And so here, one of the things you can do is go through the series and ask it, and this works also for the data frame, everywhere you have a not a number or NaN numerical entry, I want you to fill it in with this replacement that I specify as a parameter. Now, in this case, I'm specifying 0. But one of the things we'll see in the Jupyter Notebook is actually see the impact of those choices for what you fill in for missing data, because that can change the distribution of values associated with that column's worth of information. Any questions? That make sense? Yeah. All right. And so oftentimes it's useful, especially if you're going to do broadcasts. You want to know what the shape is or the rank is of that data structure. Now, a series, as we said, represents an array. And as an array, it's one-dimensional. And in this particular case, our series had 3 entries. And so we see this tuple 3, comma, and blank, right? So that says we have 3 entries, or you could think of it as 3 rows worth. But since it's a vector, I often talk about it, or often talk about it as the rank of that vector. Okay. And so here, another thing that's very useful, that same correlation that we talked about, that talks about linear statistical dependence between variables, what we've been casually saying variable or calling variable coupling. And so here in this example, we have 2 series. The first one has numbers 1, 2, 3. The second one, 1.5, 3, 4.5. So now you can take the correlation arbitrarily between 2 series using that core function. So in this case, you're saying S1, what is your correlation with this other series, namely S2? And in this case, the correlation is 1. There's a perfect linear dependence. Okay, any questions? Does that make sense? You can also take the sample mean. It's a very useful thing to do. And if you call mean on the series, it'll give you the mean associated with the vector's worth of data underlying inside of that particular series instance. If you call mean on the data frame, it'll iterate through all of the numerical entries and numerical columns and compute the mean of those. Okay, any questions? No? You can also compute the median. The median, or the middle order statistic, corresponds to the sorted order of these values. Default is in non-decreasing order. And so the median is that particular position right in the middle. And we have on the homework an exercise where you're to look up what the median is and why it's important. Any questions? No? All right. And this is pretty interesting. One of the things you can do is sample from the series. Very often, many applications, it's useful to so-called bootstrap your data. That is, treat it like it's from distribution. Treat it like it's from some distribution by sampling some number of values with replacement from an array of numbers. And so in this case, we have our series, and it's populated as a 5 array, the rank of 5, and it has numbers 1, 2, 3, 4, 5. And we're going to produce a sample of 3 values drawn with replacement from this array 1 through 5. Now, of course, I could say sample n equals 10, n equals 17, n equals 1. It doesn't matter what n is. It's going to produce that sample and return back another series that's populated with those values that are randomly sampled equal preference from the original array. Any questions? No questions? Does that make sense? Yeah. All right. And so, a really, really important, and this is where some of the power of the Pandas APIs comes in, is so-called filtering. You can select and sub-select regions of a data frame, or under various criteria, sub-select elements from the array inside of your series. And so in this case, of course, we're going to kind of walk through a typical exercise, but we're going to do something a little bit more complex than what you're going to see on the slides in the data frame. I just want to kind of get you going with the basic filtering. And so here we read in our Titanic CSV into memory. We get back a data frame, and it's very typical to want to view the first few entries from this table. Now, we talked about head last time when we said it takes a parameter n, where n is the count of the number of entries or rows in the frame that you want to display. If you don't have any parameters, the default is 5. And so it's often nice to kind of see your data sometimes to some degree. So here we extract out the ages column from our original data frame. It's the same Titanic data set that we talked about last time. And we're going to say, go ahead from the resulting series, show us the first 5 elements. So we call ages.head. Okay, so we can display that, but sometimes you want to sub-select perhaps more than one column from your original data frame. Perhaps some of the columns aren't useful to the analysis that you're trying to perform. And so in this example, you take your data frame reference and you give it an array of key values as strings, because keys are strings. And when you do this, okay, it iterates through and it says, okay, I'm going to pull out just those columns from the data frame, those name value pairs whose keys match the keys in the array. And so in this case, the Titanic data set, and I'll show you it more directly in Jupyter, it has 12 columns, right? And it's a mixed data set. Some of the columns are categorical, some of the columns are string, and some of the columns are numerical. And in this case, when I select out here, this list containing these 2 keys, I get back when I display the head of the resulting data frame that's returned to me, I get another data frame. And here I have age column, which is numerical, sex column, which is categorical. Now, in this case, I did not specify an index. And you'll see here that 0th column, or that first column, if you want to use zeros-based numbering, it's the default index. And so it's going to be 0 for the 0th offset in the resulting data frame entries, 1 through 4. Any questions? Does that make sense? And the reason this is 0 through 4 is because when you say head with no parameters, it's only going to show you the first 5 entries. If I did not say head and I just said, show me the whole thing, it'll show you all 891 entries for those 2 columns. Does that make sense? Yeah? All right. And so here, when we take the shape of that data frame that was returned, when we selected these 2 columns, you'll notice here the tuple I get, it says 891 rows by 2 columns. And so this sub-selected is an entirely new data frame, and it contains only those columns that you specified in this list when you use that slice notation. All right. Any questions? Does that make sense? Yeah? Still a little tired? Okay. So another interesting thing, you might want to select or sub-select from a column some of the entries based on some criterion. And so in this example, okay, we extract the ages column from our Titanic data frame that we've read in from CSV file. So we brought it into memory. Once we get that, we say, okay, well, show me the first couple entries, the first 5. So I call ages.head. And now I might want those particular entries where the age is, say, less than 10, right? Maybe I want to say, who are the minors, for example, or the younger children. And so when I do that, it iterates through the particular array for that column. And every time I get this condition less than 10 satisfied, I get back a Boolean true, otherwise a Boolean false. And so you'll notice here, position by position, in the ages array, I say index 0, it's false. It's not true. Index 1, it's false. index 2, it's false, etc. So we can use this Boolean result that we get, this array of Booleans representing the result of that particular logical expression. And if we put it in our array access notation for the series, we get back the values that satisfied that particular query. And so if you wanted to subselect, you have to do two things. You give the condition, which results in a Boolean array, and then you wrap it in the array access notation, and that gives you the actual values that satisfied or didn't satisfy that condition. Does that make sense? Any questions? No? Now, I did this with the series that I sliced out of the data frame. But if instead of saying ages as the array, if I said Titanic, the data frame, as my array, it's going to give me the entire set of records where that particular column entry for age satisfied the condition. Does that make sense? Any questions? I will have an example of this in the Jupyter Notebook. All right. And so here, in this example, I say, all right, well, let me take my original data set, the Titanic data set, and I say, go ahead, and I say, all right, every place Titanic age column is greater than 35, return back that entry. And I'm going to take the resulting data frame, and I'm going to assign it to this reference above 35, right? So if I go ahead and I list out the first 5 entries of above 35, here, I get that subset of the original data frame where that particular age column entry is greater than 35. Does that make sense? And so the difference is, of course, here I wrapped that condition in the array access for the data frame. In the previous slide, it's wrapped in the array access for a series, which is a single column. Okay. Any questions? No? All right. And so you notice here I have all 12 columns, but in the previous slide, I only have 1 column. Okay. Another thing you can do is you can do a selection from among a certain set of values. The P class variable or column represents the passenger class, like first class versus business class on flights. Back then they called it first class, middle class, and lower class on the Titanic. And so here we say, okay, well, Titanic, I access the P class column, and then I ask it is in, all right, what entries are in the following set, and I specify that set as an array, a comma-separated array of values. Now, of course, when you have these values have to be things that are actually in that particular column. If you specify a value of, say, 10 and there was no passenger class 10, of course, it's going to do exactly what you asked it, and nothing has a 10, so it's going to return back to you an empty data frame. And so here I say, go ahead. And when I say Titanic, access or slice out that P class column is in either 2 or 3 passenger class, iterates through, and it checks each entry in P class to see if it's in that list. Is its value 2 or is its value 3? The result of that inner selection is going to be a Boolean array. And there's a typo here. I forgot the closing square brace. I take this Boolean array from this is in query, and I wrap it inside of a Titanic array access, and I get back those entries from the original data frame where the passenger class is either 2 or the passenger class is 3. Does that make sense? Any questions? And again, I have a typo here. I just noticed that I need a closing square brace over here on the right-hand side. All right. So you can not only have logical expressions, you can use sets to subselect specific records from your original data frame that match all sorts of criteria that you prescribe. Another thing you can do is you can subselect a rectangle from this 2D array. And this looks like traditional Python slice notation, which it is. And so we take our data frame and we use the iLocation, iLock API call. And it's sort of like an array. You give it the array access slice notation. The first position is the range of rows. The second position is the range of columns. And so with slice notation, you have a starting location, colon, a stop location, and the semantics are such that it gives you the starting location up through the stop location -1. And so in this case, we're going to get rows 9 through 24 and then columns 2 through 4. And so if we do that, that's based on position. And so you'd have to interrogate the key values for your data frame to know what what the ordering is for each one of these columns that comprises your data frame. Does that make sense? Any questions? And so you can arbitrarily, and before when we referred to having duplicate columns, once you have duplicate column names, because you have duplicate key values, you have to use iloc to reference them specifically. Okay. Any questions? Yes. As the rows. So the 9 through 25 in our access iloc or location. I always try to pronounce things, but it's not always effective doing that. 9 through 25, and then we have 2 through 5. So this refers, the first slice refers to the rows, and the second, I can never make, there we go, refers to the columns. And so this says start at 9 and go all the way to 24. And this says start at 2 and go all the way to 5. If we have our original data frame, our data frame starts at row 0 and ends at 890 for a total of 891 rows. And it starts at column 0 and it ends at column 11 for a total of 12 columns. And so now it says, okay, start at row 9, and this is not to scale. Maybe 9 is over here. Row 9 to row 24, and it's going to go column 2 to, say, 5. And this is, again, not to scale, 2 to 5. So it's going to slice out that subrectangle. Nope, that's not right. Let me do that. 2 to 5. That subrectangle from the data frame. And so the first position is the row range. The second position is the column range. But this is the semantic of the Python slice notation. It's always the stop index -1. Okay. Any other questions? Does that make sense? All right. Let me check my headphones because if I go out of range, it drops the headphones. Okay. Hide. All right. Any other questions? No? And so you can also sort using a so-called sort key, specifying a column as a criterion for which you sort the entire table's worth of data. So in this case, we have our data frame, Titanic, and we call sort_values, and then we give it this by specification, and you give it the name of a column, a key value for one of the columns, or the series. You can use those as synonyms, and it'll go ahead and reorder the entries of the table based on the age. And in this case, you see that the smallest age is 0.42 years, and the largest age, I think it's 80 in this data set. Okay, any questions? Does that make sense? Now, you'll notice here that if we look at that 0th column, it preserves the original default indices, right? And so whichever started out as in position 803, starting from 0, that has the smallest age entry. If you chose to, you can tell the data frame, go ahead and reorder the indices starting from 0. But when you do this sort, sometimes it's useful to know what row in the original version of the data frame represented the first record sorted by that particular criterion, age. Any questions? Yes, yes. If you slice it, it's gonna it's gonna give you. That's a good question. Well, let's ask Python. Let's try that out. It should give you the original indices because it'll preserve, like, say, 803 in that zeroth position, unless you tell it relabel this as zero for that particular sorted order. But we can certainly try that out in the Jupyter Notebook. Okay. Any other questions? Does that make sense? Okay. And the reason why I think that's useful is that if you sort it by age, and then let's say at some point you sub-select it, so then you just have name and age, right? Sometimes it's useful to be able to refer back to the original data frame and say, oh, where did this come from? You know, maybe there's other information you want to look up. But there are all sorts of reasons why you might want to preserve it, and there are other reasons why you might want to relabel it starting at zero. Okay. So let's take a look briefly at visualization. Of course, we talked about histograms, and histogram method is associated with the series as well as the data frame. We showed last time for the data frame, if you call a histogram and you don't give it any parameters for the bin count, it'll default to 10 bins. But you also have these visualization methods or functions available on the series objects as well. Okay. Um, Here's an interesting one, cumulative sum. And in this case, I've created a series with random data. And I've also, and we'll talk more about time in Python and Pandas more specifically in the future, probably in another week or so. And you can create a date range for your index. And the index, again, is just a relabeling or overriding of the default index, which is just a numeral. And here we've relabeled them or overridden them with dates. And so here you can see, and we'll another time talk about the details. We've created a date range, and you can specify a starting date and the number of periods. And in this case, it'll increment by days, right? And it'll do that calculation for you, which is why the time APIs are very, very helpful. And in some cases, you might want to have a cumulative sum, a running total. You take the first measurement, the second measurement, the third measurement, and you accumulate them and plot the sum. That's useful, for example, if you want to, you're a retail concern and you have revenue for one day that you're reporting. And if you want to know how much you've made over a month, you want the cumulative sum over each day of the month, totaling all of the sales for each day. Okay, any questions? No? All right. So in this case, we take the cumulative sum and we're given back another series with our cumulative sum. And we'll go ahead and call the plot API. That's a line plot. Okay, any questions? No? All right. And so where it's also very useful is because these APIs for visualization use the underlying data within the series or within the frame, you don't have to sit there and pass these arrays all over the place like you did in the visualization API for the spaghetti meatballs problem, I think project number 2. But any questions? No? Make sense? Let's check the time. Ooh, we have half an hour left. So, of course, always try stuff yourself, right? We're not going to cover all of the variations of all of the APIs. There are too many of them to cover in a course. And so I strongly encourage you to tinker with it, ask the runtime your questions, try them out. And the documentation is quite good. There are lots of examples all over the internet. But I tend to prefer the official documentation of record because those are the folks that implemented the API. Okay, any questions? No? So we have about a half an hour left, maybe 26 minutes. And we're going to spend the balance of today going over a couple things in the Jupyter Notebook to see some of these things in action. And so because we're going to be using the Titanic API, and my wife asked me, this is a private joke, but are you going to play the video? It's like, yes, I am. So in honor of the Titanic, I don't know if you're a Celine Dion fan, but I don't have a Grammy, so kudos to her. Um, all right, I'm not going to play the whole thing. This is just a private joke. I was, well, anyways. So why don't we switch um, to the Jupyter Notebook, and I'm going to stop the share, and I'm going to reshare because every time I exit PowerPoint, it seems to drop the other share. So I'll make sure I have it. So where we left off last time in our data frame, among other things, we read in the CSV file, okay, and we got our data frame. And here we plot the first 5 values of the entries from the data frame. And so here down below, we can slice out the age column. And if we display that, here we have the age information. And you'll notice here we have the default index, and it starts at index 0 and it ends at 890 for a total of 891. And so that note is more for myself. One of the things you'll notice here, let me add another cell, is that we have not a number entry inside of this. If I said age info is not a number, I go ahead and it returns back a Boolean array or series populated with Boolean values with true, false, depending on whether or not it was not a number. And so any place you see true, you know there's going to be not a number entries. So why don't we go ahead, and fortunately, a Boolean true underneath the covers is a 1, and a Boolean false underneath the covers is a 0. So we can actually sum together that those entries of the Boolean array, and it'll tell us, oops, if I spelled that right, sum, um, it'll tell us how many entries have not a number. So there are a total of 177 of those 891 entries that have not a number. And so the choice, and we'll see that in the other notebook, of the choice of what you do when you have these missing entries is going to dramatically impact the distribution of at least the ages. Because 177 out of 891 is fairly significant in terms of proportion. Okay, any questions? No? All right. And so now one of the things we can do, sort values by. Okay, let's do that one. Let me add another cell, and I'm going to take the original data frame that I called CSV file, and I'm going to say CSV file sort values by equals age. Okay, so let me do that. Let me assign it to sorted data. And I will post this Jupyter Notebook on the Moodle site. No, on the Canvas site. She used to say Moodle. So I have sorted data. Let me add another cell. Run that again. And if I say sorted data head and say the first 10 records, notice here, I get that reordering that we talked about. And if I scroll over to the age column, I see is 40.42, 0.67, 0.75 in non-decreasing order. Does that make sense? Any questions? No? Likewise, let's see. I think I did min, max, and histogram from before. You can compute all sorts of summary statistics, but on the next notebook, I'll experiment and show you the impact of on the distributions of different choices for filling in values for not a number. Question? I'm sorry? Yes. I'm having a little bit of trouble hearing. Yeah. You could have, but it was on purpose that I said, um, any other questions? No? So why don't we do this? Let's go to this next data frame, And I've pre-populated it with a bunch of functions. And this time I'm going to call it DF, like all the umpteen many examples that you see for data frames on the web. I don't know why I called it CSV file before. And so it's in its original form. It's not sorted. And we're going to come down here. And one of the things that's useful is to get an enumeration of a list of all of the key values. We said that a data frame is nothing more than a dictionary of lists, a number of name value pairs where the values are arrays of information. And so here, if I say go ahead and give me all the keys, it's going to give me all those names associated with those dictionary entries for each one of the columns. And so I have 12 keys. I have passenger ID, survived, passenger class, name, sex, age, SIB, SP is the number of, what was it? Oh, there we go. The number of siblings aboard. So this information was curated from the manifest of the Titanic cruise liner, which met an untimely fate, colliding with an iceberg and it sank, and many people perished. And so that being the case, for this data frame, we have 12 total columns. And by enumerating the keys, you can get a list in order of how those columns occur. And so in this case, if we were to use iLock, we could slice out ranges of rows and ranges of columns. But for the columns, it's important to know what the ordering is of those entries so that you're getting what you think you are if you do that slicing to get a subrectangle from the original data frame. And so here, let's do a number of experiments. And we're going to say age info is equal to a data frame, and we're going to access the age column from that data frame. Okay. And once we access that, let's go ahead and fill in not a number with different values. And so the first thing we're going to do is, let's say age info histogram. And because we know the min, let's say the min is, I think it's 0.42. Oops. Why didn't that? Let's see what happened here. Min, okay, 0.42. Age info max, I think it was 80 years old. And let's go ahead. So let's set our histogram bins, since it's 0 to 80. Let's set it to 80 bins, right? So let's say age info histogram bins equals 80. Because we're going to go through, and everyone who's between 0 and 1 and 1 and 2 and so forth is going to be counted in a separate bin. So we do that, and this is our original distribution. So let's go ahead and let's do some manipulation on this. So we have not a number entries, and when you have not a number entries, in computing your histogram, it goes through. It doesn't have a value for not a number, so it excludes that. So let's go ahead and let's say age info fn is equal to age info fill not a number with 0. So that means everywhere it sees not a number, it's going to substitute a 0. So now, after doing so, we have numerical values for each one of these not a number entries. So let's look for, I misspelled that, age info. Let's another one, let's say mu, age info, and we're going to fill na with age info mean. And here we're going to replace all those not a number entries with the mean. So we have two versions of age info. One version, we have replaced not a number with 0, and the other, we've replaced not a number with the mean. So let's plot them. Figure, let's say 2, and we'll say, oh, we don't have the plot API. Let me just plot the histograms. Age info fn histogram bins equals 80. And let's see what that looks like. And we notice here, when I do that, the shape has changed quite dramatically. You'll notice here over the 0, there's a large spike over zero. And that is all the entries that 177 of them, for which I've replaced with the value zero. That's not a number of value zero. And so that is going to skew or change this distribution, favoring more smaller values than it should. In the original distribution here, the bulk of my population is between about 18 and say 50. But this is going to change statements that I make based on this particular transformation. So let's take a look at the other one, add another cell, and let's say age info, the mu version, histogram, bins equals 80. And let's see what that version looks like. So now when I do that, my spike is at the mean, the middle, right there around 30. I'm not going to skew it to the left or to the right. Anything I say about this population or this version is going to tend to look at the central value anyways. And that's a much more desirable behavior. Now, you could decide to so-called reject outliers. You take those values that are atypically small, you take those values that are atypically large, and you throw them out. Everything else is more typical of your population. And we'll talk in the future about schemes for how you might decide whether something is atypical on the high side or the low side. Okay, any questions? Yes. Mm-hmm. Yes. Ah, the middle between the two. Yes. There's another model called a mixture distribution. And you make the assumption that you have two distributions. And then given those two distributions, you can look at the cut point between the two, and they actually have separate means. And so there you would make a different type of modeling assumption instead of just a single distribution. But at this juncture, we've only talked about single distribution. We could certainly add that to the set of topics if people are interested. But yes. Yes, you want to center it around the mean. The mean is that center. But if you make the model assumption that you have more than one instance of that distribution, then you have two of those means, and it becomes how do I assign the means, and how do I assign points to one of those two distributions that so that they have desirable qualities of compactness. And there are specific algorithms that allow you to do that. And so in that particular case, here, we're making the assumption that we only have a single distribution. And because there's only a single distribution, it only has one center, right? But if we made the assumption that we have two distributions, now, for example, if we had a population and let's say we make the assumption then say something like the population. Not and then value is which version of sigma standing vice versa. But in another treatment, if you made the assumption that the structure of our population was bimodal, then you say, okay, I have distribution, and maybe this is the younger group, and maybe the older. Then I say, and older. And now, if I set now narrow, and that's what expectation allows. And you can do that with phone, remote, and mode, with all the assumptions that you make about this change in this case, or assumptions that this case. Any other questions? All right. And so When we get to the part about extracting insights and modeling, expectation maximization is the form. And we'll talk about some considerations. All right. Any other questions? No? That makes sense? All right. So we have about 12 more minutes. So let's make some considerations. We talked about correlation. Suppose we wanted to look at the impact of dropping records. Okay. Suppose we wanted to know what percentage of our passengers were teenagers, right? Okay. So we would say, all right, age info is greater than what 13 is teenager. And at the same time, age info. Oh, I'm mixing Java and Python. Fix that. And okay. And age info is less than, is 19 really teenager? 19 is teen. Well, I know it's 19, right? But all right, so let's do that. So if we did that, let's see what we get. Oops, I think let's do it one by one. Age info greater than 13. Okay. Age info greater than 13. I know you can do it. Let's see. Let's do this. And filtering and condition. I forget how to do that. Oh, single and. Okay, yeah, that's what I thought it was. All right, so let's go back. And age info less than 19. Okay. Let's see. Let's just for good measure do that. I'm gonna let's see, blah blah blah. Okay, let's do that. There we go. And so these are the teenagers. Let me say the teens. So I'll grab that. And let me say num teens. Oops, num teens is the teens shape 0. Okay. And so there. And so I have 891, and this is sort of bad Python, but in the interest of time, print teen proportion num teens over 891. I'd certainly measure it instead of just doing this. So now I'll say print formatted teen proportion is teen proportion, and we'll do that. Okay, so let's print that out. So we have about 7.63% were teenagers. Okay. And so here with the filtering, not only can you use one condition, but you can use an arbitrary logical statement, a conjunction of conditions. And I can use and, I can use or, all sorts of constructs for logical expressions. Does that make sense? Any questions? No? All right. So that's the number of teens. If I wanted to know how many or what percentage were minors, I would define what a minor is. If a minor is under 12 or if a minor is under 18, depends on your standards. And so certainly historically, a minor back in 1920, 1950 is different from what's considered a minor now. So you'd have to put this in historical context for the time. Okay, because generally after high school back then, people were considered, grown, so to speak. So let's look at the proportion that survived. We'd do the same thing. We'd count how many were survived, divide that by the total number 891. So let's go to this part, which I really wanted to take the opportunity to show you when we're looking at the conditional probability. Now here I've included what the individual columns mean, and I won't go over that. It's important to know what your data means. But down here, I implemented the conditional probability, and that's what I want to refer you to on the board in the next 5 minutes. And so we talked about a conditional probability as starting with your universe of consideration. Those are all of the objects under consideration. And in our case, each object is a row from our data frame. That's an individual. And an individual has various descriptors, and we have a total of 891 objects in the universe. So when we say given B, our condition, we're now setting aside only those objects from the universe that satisfy that condition. Now, we could say given B is a certain value, like if it's male or if this attribute is female, we will go through this 891 records and we compute a new universe of consideration. So no longer do we consider all 891, we only consider that subset of the 891 that match that particular condition. Now, from that new universe, now we count our favorables. And that's going to be the probability of the A part. And we use this new universe of consideration. So given that, no pun intended, here we have probability of A given B. And one of the wonky things about your Jupyter Notebook is that when you have a function, that function has to be in a single cell, because a cell is a unit of execution, right? You put your cursor in a cell and you say, go ahead and execute what's in that cell. A function is a block of behavior, and that block of behavior, if you straddle it across two different cells, all it sees in the second cell is just an indented set of code, and it has no idea what you're trying to do. And so whenever you define a function in Python, if you're going to have it in your Jupyter Notebook, you have to have that whole function block in a single cell. Now, that being the case here, probability of A given B, what you need to know is what the variable is for A. And that variable, we're going to use the key names or the column names from the data frame. And then the value that it takes on is one of the values that it can have in that column. And so here we have probability of A given B, and given B is a particular value. And so for our parameters, we have the A variable, we have the A value, we have the B variable, we have the B value, but we're not done yet. We need the original universe of consideration, the universe. And the universe is going to be your data frame that you started out with. So we start out, first, any questions? No, does that make sense? So we start out and we say, okay, well, we said given B. And if we're given B, we said we need to compute a new universe of consideration, that subset of our original universe where that B condition is true. So we start out and we say, okay, well, we get that B variable, that particular column from our universe. Okay, that's going to be a series called the B series. And now we say, okay, we're going to filter all of those entries from the universe, all of those rows, where that particular series for that B variable is equal to B value. That's another type of filtering. Now, when we saw with ages, we said less than, we said greater than, we said less than and greater than, but you can also use equality, right? So this is exact match. And so we're doing filtering and we go through our entire data frame and we pull out those records where this particular column corresponding to B variable is equal to that value. And then we're going to print out the shape, and that's now the total number. And when we compute our probabilities, you still have NF, the number of favorable, divided by the number of total, NT, but NT is going to be the count of the number of rows in this new universe. Does that make sense? Any questions? And so this filtering is really, really useful for evaluating programmatically conditional probabilities. So now we say, okay, the new universe is the result of this filtering, the setting aside of those entries from the data frame that match the condition, okay? And now for this new universe, we're gonna take out the series associated with this A variable, because the new universe is a data frame that contains a subset of the rows from the original data frame, our universe of consideration we started with. So now we call it A series. We strip out that column for the A variable. And then for the favorable, we say, okay, out of our new universe, how many of the objects, the rows, have this condition for A equal to true? And that's this colored in region on the board. Does that make sense? And so that's going to further subselect from the new universe that subset that correspond to that A condition or A attribute being true. And we use filtering to do that. So from this A series, we're going to look at all those values, those records in new universe that have this particular value. And we're going to count the number of favorables. And so now we're going to print out, and our probability is nothing more than the number of favorables over that new total, which is the count from the universe, into the new universe. Does that make sense? All right, any questions? Yeah. All right, so in the next 2 or 3 minutes, we're going to call this, and we're going to compute the probability that somebody survived, so survived equals true, given that they were female, right? And so we do that, okay. It's about 74%. So what if we wanted to say given that the person was male? Okay, we do that. That's 18% and 18 change. What if you said probability that they did not survive? False. Given that the person was male. Okay, that's about 81%. And what's the probability that they survived, given that they're male? Okay, so we could say probability that they did not survive, false. Oops. Given female. Okay, 25%. Probability that they did survive, given female, about 74.2%. And so these conditional probabilities, it's exactly like we talked about. And filtering is immensely useful for evaluating these constructs. Now, this is just a couched example, right? It's Titanic, CSV, not that many records. But you can imagine if we had a data table from the airlines industry, right? And you can get these things from the FAA, Federal Aviation Administration. And what if you had a whole year of flight information? Did it depart on time? Did it arrive on time? What was the airport code for the departure city? What was the airport code for the arrival city? Maybe some encoding of the weather. Now you can ask all sorts of probabilistic queries. If I take Delta from Worcester Airport and it's rainy in the Midwest, what's the probability that I'm going to arrive on time? And you can perform all sorts of queries with that. And if you can perform the queries, because they're probabilities, you can also sample or produce fake data and now ask this questions, right? And organizations like airlines do exactly that. And based on the results they have, they do things like pricing. How much are we going to give you to keep you happy because you got bumped from a flight and things like that? Of course, the difference is the queries might be more complex. What we're given wouldn't be a single variable. It would be the ANDing or the conjunction of a set of variables. But with these conditional probabilities and Bayes' rule, we can ask all sorts of queries. The only difference is just a much larger data set. And you can imagine if you had all the major airlines carriers and you had like maybe 50 to 100 different attributes, you could deal with several gigabytes easily worth of data. And these queries would take a much longer time to calculate. Any questions? Does that make sense? So that's the part that I really wanted to show you is it's exactly like the tennis balls example, and we are over time by about 1.5 minutes. So let me end there, and I will stop the recording and stop the class, and I'll see you all on Friday. Okay, hey.